Okay, this is the solution video for practice midterm number 1, version 2. Problem number 1, let L be the line given by this parametric equation. Part A, find the symmetric equation of L, symmetric equation. So here's the answer. To get the symmetric equation, you have to read off the direction vector and one point the line goes through. And to get the direction vector, what you have to look at is the coefficients of t. So in this case, a direction vector is 1, 2, -1. And then also at t is equal to 0. So you have to find one point the line goes through, but that point can be any point, but the easiest way to look at is to set t is equal to 0, we get -1, 2, 1. So this is the point. This is one point the line goes through. And from this, you can write the symmetric equation as x minus 1 over 1, y minus 2 over 2, and that is equal to z minus 1 over -1. This is fine, but if you like, you may rewrite it as x plus y is equal to y minus 2 over 2, and that is equal to z minus 1 over -1. All right, so this is a part A. Now for part B. For part B, the question is, find the point of intersection of this line L with the xz plane. So here's the answer. xz plane is the same as saying what? Well, that is the set of all points where z coordinates is always 0. So this corresponds to y is equal, I'm sorry, not z coordinate, y coordinates is 0. So y is equal to 0. So that means in order to find the point of intersection with y is equal to 0 and this line, what you have to do is to find the parameter, so the parameter t, the value for the parameter t, so that y is equal to 0. So this gives you y, which is 2t plus 2, and that's equal to 0, and that is equal to t is equal to -1. All right, so now at t is equal to -1, the x value and the z value are computed in this way. So x is equal to -1, -1, that's -2, and z value is negative t, -1, plus 1. And that's 2. So therefore, the answer is x is -2, y is 0. That's how we have chosen t. So y is 0, and z is 2. So that's the answer. All right. So this is a number 2. Let A and B be vectors like those, vectors in R3. Number 1, I'm sorry, part A, find the area of the parallelogram spanned by those two vectors. Now, here's the answer. Let's remember, how do you find the area of the parallelogram spanned by two vectors? Well, if this is A and this is B, and then the parallelogram spanned by the two vectors is this parallelogram. So you want to find the area here. But let's remember, this area is precisely the magnitude of the cross product A and B. So the cross product is always perpendicular to both A and B, and the magnitude is precisely the area here. So what you have to do is to compute the cross product first, and then compute its magnitude. So let's compute cross product. Cross product ijk I, J, K, 1, 1, 1. This. And then this is what? Well, 1, let's just look at this. 1, 1, 2, 4. I minus. You look at, you hide those. And then 1, 1, 1, 4, J, plus, and then look at this part, 1, 1, 1, 2, K. All right, and then if you work this out, you are supposed to get a 2I minus 3J plus K, or you may write it as 2, negative 3, 1 if you like. All right, then now, so therefore, the area we are looking for, the area of the parallelogram spanned by dots is, like I said, the magnitude of the cross product. And that's just the magnitude of this vector. That's squared plus 1 squared and square root. And that's equal to root 14. So that's the answer. So this is a part A. Now, this is a part B. Let theta be the angle between those two vectors A and B. A and B is the same as those two vectors. Then now the question is, find a cosine of theta. So here's the answer. So let's remember, how do you find the cosine of the angle between two vectors? Well, here's the formula. A dot B is the magnitude of A, magnitude of B, and the cosine theta. So from this, you'll see that the cosine theta is A dot B magnitude of A, magnitude of B. So therefore, what you have to do is just compute the dot product and the magnitude of each of the vectors. So let's remember A is, let me just copy it, 1, 1, 1, and B is 1, 2, 4. So A dot B is what? Well, one dot product of those, that's 1 plus 2 plus 4, that's 7. And now, magnitude of A is what? Square, square, square. That's 1 squared plus 1 squared plus 1 squared. Square root, that's square root of 3. Magnitude of B is 1 squared plus 2 squared plus 2 squared plus 4 squared square root. And that would be what? Root 21. Okay, so therefore, cosine of theta is 7 divided by root 3, root 21. And this is actually simplified as 7 over 3 root 7. Okay, well, if you like, you may rewrite it as this. It doesn't matter. Okay, so that's part B. All right, this is number 3. Find the equation of the plane that contains those 3 points. 1, 2, 3, negative 1, 1, and negative 1, 2, 4. And here's the answer. So let's call those 3 points A, B, C. So let's label the points as A, 1, 2, 3, B, negative 1, 1, 1, and C, negative 1, 2, 4. So you have 3 points in the XYZ space in 3 dimensions, and that makes a triangle floating in the air. Then now the question is find the equation of the plane that contains those 3 points. So we have, so picture is like this. A, somewhere around here we have A, somewhere around here we have B, and we have C. We have a triangle. Okay. Then now we want to, so that means if you have a triangle that determines a plane in the XYZ space like this, then now the question is what's the equation of this plane? Then now, no matter what the question is, to find an equation of a plane, there are 2 pieces of data you have to find. 1 point the plane goes through, no matter what, doesn't matter, just pick up 1 point the plane goes through. And in this case, we could choose any one of those. So we are done with that. And then we have to find a normal vector, namely a vector perpendicular to the plane. Then now, how do you find the vector perpendicular to the plane in this case? Well, here's one way to do it. Let's look at the vector AB and AC. So here we have vector AB and we have vector AC. And those 2 vectors are on the plane. So that means if you find a vector perpendicular to both vector AB and vector AC, and then that's gonna give you a normal vector. But what kind of vector is that? Well, typical way to find a vector perpendicular to both is to take the cross product. So that's gonna be our normal vector. So after all, the question boils down to finding this cross product. And to do it, we have to find those 2 vectors in terms of components. And those 2 vectors can be computed by looking at those 2 points. Namely, vector AB is what? Remember how to find the displacement vector from one point to the other? What you have to do is subtract one from the other. Minus 1, 2, 3. Strictly speaking, the reason you get this is because you have A here and you have B here. Let's see. You have A here and you have B here. And somewhere around here you have the origin. And then vector OA is this vector. And this vector OB is this vector here. The vector corresponding to the position vector. And then the vector here, AB, is precisely OB minus OA. So if you reverse OA, and if you start from here, go like this, and that's the same as AB. That's why you need to subtract. Anyway, so this is equal to what? Negative 2, 1, negative 2. Negative 2, negative 1, negative 2. And similarly, vector AC is computed as negative 1, 2, 4, and 1, 2, 3, and that is computed as negative 2, 0, 1. Okay, so therefore, the cross product we're looking for, vector AB cross vector AC, is IJK, negative 2, negative 1, negative 2, and negative 2, 0, 1 magnitude. And then you will see that this is negative 1, 6, 2, negative 2. I'm not going to do the detailed calculation. This is exercise to convince yourself why this is so. And like I said already probably several times, to check if your calculation is correct for cross product, what you should do is to compute the cross product of dots. I'm sorry, not cross product, dot product of dots, And you are supposed to get 1. You are supposed to get 0. And in this case, you get 2, negative 6, plus 4, and that's certainly 0. So it's okay. Then now, also you take the dot product of those two, you get 2 plus 0 minus 2, and that's 0. So therefore, this vector is indeed perpendicular to those two. All right, so this we use as our normal vector, and as a 1 point, the plane go through, we could use 1, 2, 3. It doesn't matter, you may use this one or this one, doesn't matter. And then, so that means the equation for the plane is given by -1 times x minus 1. Okay, this comes from here. And then plus 6 y minus 2 plus negative 2 z minus 3. And that is equal to 0. Okay, so what you see here comes from the normal vector, and you subtract the coordinates of the point from each variable like this. All right, and then if you simplify this, you are supposed to get x minus 6y plus 2z plus 5 is equal to 0. All right. Then for those numbers, instead of a, if you use b or c, it looks different. It would look different, but once you simplify, if you simplify this expression, you are supposed to get the same answer anyway. Okay, so this is a number 3. This is a number 4, part A. Let A and B be vectors in R3 such that the magnitudes are given this way, 2 and 3 respectively. And moreover, let's assume that A and B are perpendicular to each other. A is perpendicular to B. Then now, compute this dot product. Okay, here's a way to do it. So you want to compute this. But we don't really know explicitly what A and B are. The only thing we know about A and B is first, the magnitudes are 2 and 3, and then A and B are perpendicular to each other. Well, how should we do this? Here's a way to do it. This one here is what? Well, remember dot product, it basically works in the same way as multiplication of numbers. Namely, you can foil it like what? Like this and this. 2a dot a minus 2a dot b, and then now you can foil it, plus b dot a minus b dot b. Okay, then now what? Well, what is a dot a? Remember, if you take the dot product of vector with itself, what you get is the magnitude of the vector squared. So this is 2 times a squared. Don't forget squared here. Minus 2 times, what is a dot b? Well, we don't know what a dot b is, but we do know that a and b are perpendicular to each other. A is perpendicular to b. So therefore, if two vectors are perpendicular, then if you take the dot product, you get 0. So that means this is negative 2 times 0. And similarly, b dot a is just 0. Minus b dot b, that's the magnitude of b squared. And that is 2 times 2 squared. And those are 0. Those two terms are 0. And then minus a 3 squared. And that is equal to negative 1. So that's the answer. Problem number 4, part B. Find all number a so that this vector 1a2 is perpendicular to the plane given by this way. What does that mean? Well, this means this, right? So you have a plane. This is a plane, let's say. And then So that means if you look at the coefficients of x, y, z, what you get is the normal vector, the components of normal vector. So this plane has normal vector 2, 1, 4. Then now you want to find the value for a so that this vector 1, a, 2 is perpendicular to the plane. So that means you wanna choose the scalar a so that vector 1, a, 2 is perpendicular to this plane. So that means from this picture, you will see that we need to have this parallel to this. So we need to have those two vectors parallel to each other. So that means we need to choose. Need to find a so that this vector 2, 1, 4 is parallel to 1, a, 2. But what do you mean parallel? Well, parallel means one is a scalar multiple of the other. Wait. Let me just change the order. This vector is parallel to this. If you extend or shrink one of the vectors, you get the other vector. That's the meaning of parallel. So we need to have this. And from this, what do you have? Well, here, this is 2k, k, and 4k. So therefore, you get y is equal to 2k, and then this gives you k is equal to 1/2. Then now, if k is 1/2, indeed 4k is 2, so that's fine. And then therefore a is equal to, and then therefore a is equal to k, but that's 1/2. So the answer is 1/2. Okay, here. So 1/2. All right. So this is a number 4b. Now, this is number 5. Let C be the curve, or space curve, so to speak, given by this a vector function. So it's some curve in R3 in 3 dimension. And now, question number 1. Compute a unit tangent vector of C at t is equal to 0. What is this? Well, so suppose you are here at t is equal to 0. At time t is equal to 0, you are here. And the unit tangent vector is a vector tangent to the curve with magnitude 1. It's a unit vector. Then now, if you remember, if you compute the derivative, you always get a tangent vector. But that might not have magnitude 1. So you want to divide the vector by its own magnitude, and you make this into a unit vector, and that vector is denoted by big T of t. So big T of t is r prime t and divided by its own magnitude. But then now, what you want to do is to find a unit tangent vector at t is equal to 0. So we need to find t of 0, and that the derivative 0 divided by the magnitude. So all you have to do is just compute the derivative evaluated at 0. So let's first compute the derivative. For derivative, you get, what do you get? Well, this is 2t plus 1 I plus, you plug in 0, you get you plug in 0, you differentiate, you get 1 plus 2 sine t j, and then you differentiate it, you get negative 2 cosine t k. All right, and then you plug in 0, and you get I plus j sine 0 is 0, cosine 0 is 1, so it's negative 2k. So that's the derivative evaluated at 0. Then now you compute the magnitude. That's 1 squared plus 1 squared plus negative 2 squared and square root. And that is root 6. So therefore, the unit tangent vector at 0 is the ratio of those, well, 1 over root 6 times I plus j minus 2k. That is, but that's fine, but you may rewrite it as. So that's the answer. All right, and now part B, find an equation of the line which is tangent to C. C is this curve, the curve we are working on, at t is equal to 0. Now, first of all, this is a question to find an equation of the line, and it just says an equation, so you may write your answer either as a parametric form or symmetric form, doesn't matter. And then, but either way, to find an equation of line, what you have to find is two pieces of data. The direction vector and the one point the line goes through. And now for this case, let me just copy the same picture. This is r of t. And then at t is equal to 0, tangent line is a line which is tangent to the curve. So this is the line we're looking for. And then we want to find the direction vector, but direction vector is any vector tangent to the curve like this. So therefore, we could use r prime of 0 as our direction vector. So use r prime of 0, r prime of 0, as a direction vector. And then it goes through this point here. And what's this? And the line goes through. R of 0. But what's this? If you plug in r of 0, what you get is, you just plug in 0 here, 1, negative 2, negative 2. So that's the point the line goes through. So it's 1, negative 2, negative 2. Well, strictly speaking, this is the vector, well, the position, this corresponds to the position vector the line goes through, but it doesn't really matter. We often identify a vector with its corresponding position vector at the point. But anyhow, so the upshot is the tangent line has r prime 0 as a direction vector. R prime 0 is what? 1, 1, negative 2. Sorry. Let me just move it here. R prime 0, that's 1, 1, negative 2 as a direction vector, and they go through 1, negative 2, negative 2. So by using parametric equation, x, y, z is written as what? Well, it goes through this 1, negative 2, negative 2, and plus t, negative 2t. The coefficients of t's give you the direction vector. Or if you like, you may rewrite it as a symmetric equation. As a symmetric equation, this is written as y plus 2 and z plus 2 divided by negative 2. Okay, so that's the answer for this question. Okay, problem number 6, part A. Let f of x be this function of two variables x and y. Compute f sub x, namely the partial derivative of f with respect to x. So what you want to do is to differentiate this function with respect to x. Well, let's do this. Here's our answer. So you differentiate this with x. Now this is a product of two things, x and this. So this is 1 times e to the power of xy squared plus, by the product rule, leave x, and you differentiate this. So this is e to the power of something. So this stays as e to the power of something, and then you multiply the derivative of this something. And you differentiate with x, you get y squared. Then now, the second term, it looks complicated, it looks horrible, but there is no x appearing here. So this is purely a function of y. So therefore, if you differentiate this with x, you get 0. Namely, you treat this as a constant. No x appears. So this is a constant. So if you differentiate constant, you get 0. So therefore, the answer is, if you simplify this a little bit, xy squared e to the power of xy squared. So that's the answer for this question. All right, so this is the last question, number 6, part B. Let f of x be x squared plus y, and sketch the level curves for z is equal to f of x at those z's. So z values are like elevation, right? At elevation at -2, -1, 0, 1, 2. And then now, so the idea of level curves was something like this. Basically, you fix for each fixed z value, so z is equal to k, we get k is equal to f of xy, that's x squared plus y. And then this is viewed as a curve on the xy plane for each fixed k. And then this is solved as y is equal to minus x squared plus k. Okay, so therefore, this is a parabola opening up downward with y-intercept k. And then as you change k from -2 to 2 like this, what you do is to just change the y-intercepts of the parabola. So you can sketch those curves on the xy plane like this, xy. And then, now if x is -2, y-intercept is -2. And it's a parabola opening downward. This is -2. And then, so this is -2 and then -1. It's the same parabola, you just parallelly translate. And at the 0, it touches the origin and then goes like this and it goes like this. You just translate parabolas like this. This is k is equal to -2, k is equal to -1, k is equal to 0, k is equal to 1, and k is equal to 2. Okay, so essentially if you draw a picture like this, that will be enough. All right, so this is the end of the practice exam.